So if loop quantum gravity turns out to be a better way of thinking about quantum gravity, then the obvious implication, of course, is that space is indeed quantized. There's an ultimate quantum of space, quantum of area, quantum of volume. And that has quite big and profound implications for the way we understand things like singularities. Singularities at the centers of black holes or at the very beginning of the origin of the universe in a Big Bang are unavoidable consequences of Einstein's general theory of relativity, because space and time are assumed to be continuous. And anything continuous can be infinitely divided or compressed, giving rise to the notion of a singularity, where effectively it's infinitesimally small or compressed. Now, if there is a natural limit to how much you can compress space, because it's quantum in nature, then that immediately gets rid of singularities in the theory. And in fact leads to a rather interesting possibility, in that the origin of the universe was not a Big Bang, but possibly a big bounce. The idea being that what we were witness to, or are witness to, in terms of the evidence we can see for a Big Bang 13.8 billion years ago, is in fact the result of the universe that went before, shrinking and compressing down to a very, very small scale, but ultimately then expanding as it hit the buffers, as it were, as it hit the ultimate quantum of space and emerged on the other side, if you like to think about it that way, and expanded to produce the universe that we see today. If that is the case, then there are some subtle differences in the way that the spectrum of cosmic background radiation in terms of temperature variation should look. Unfortunately, the prediction from loop quantum cosmology is that this happens at scales where the data that we can derive from observations, most recently from the Planck satellite, the data are particularly noisy, or their error bars are large. And at the moment, we can't make a definitive decision to say this theory versus the standard Big Bang model predicts a better spectrum than, let's say, loop quantum gravity, or the other way around. But the day will come, I'm sure, where we can, in fact, with more observations, more precise, more accurate measurements, actually possibly make a definitive decision. The data will tell us whether one theory or the other gives a better description, and that's fundamentally fascinating.